Dear students, I welcome you for the today's lecture related to the understanding of reboilers in the in the subject of heat exchanger. Now basically the reboilers, they are used with a distillation column to vaporize the fraction of the bottom product. That means in a distillation column we are having attached a condenser at the top, and at the bottom it is attached with the reboiler. That means the liquid goes into a reboiler and the vapor comes back into the column, and from bottom we are taking out as the product, and vapors, they are going back into the column. So this is a reboiler, basically to boil and to generate the vapors which are helpful for the process of distillation. Now in this, the types of reboilers, that is the forced circulation reboiler, thermosiphon reboilers, they are also called as natural circulation reboilers, and third type, that is the kettle type reboilers. So we are understanding these three types: forced circulation, thermosiphon or natural circulation, and the third is a kettle type reboiler. Now the choice of this reboiler or the vaporizer, basically they generate the vapors, and in a distillation column the same liquid that is boiled again and again, and that is why it is called a reboiler. Choice of the best type of reboiler or vaporizer for the given duty, that will depend on the nature of the process fluid, that is what is its viscosity, whether the fluid is fouling or whether it is a slurry. So that is the physical properties of the fluid, nature of the fluid that is there. Then the operating pressure, whether the distillation column is at a higher pressure or under vacuum, that depends, and accordingly your reboiler, that behaves differently, or the selection of that reboiler is based on the operating pressure. Then equipment layout, the availability of the fixing, availability of the space for fixing the exchanger, that is particularly the headroom that is available. Headroom is the space to accommodate the vapors in a closed vessel. If there is a liquid that is provided inside the vessel, in this vessel the liquid that is available up to this height of 50% or 60% liquid that is there, this is what the liquid which is available, and the space above this liquid, that is called the headroom or the head space, that is available in case of our reaction vessels also, where the more headspace that is provided depending on the boiling point and the operating temperature. If the boiling point, if the operating temperature is near the boiling point, then more vapors will be generated, and as a result one has to keep a more head space to accommodate those generated vapors, so that the vapor will be sufficient, will not create, vapor pressure will not create a chaos into the vessel. Now one by one, the forced circulation, natural circulation, and the third is the kettle type reboiler. First is the forced circulation type reboiler. In this case, the pump that is used in the forced type of forced type of the reboiler, the pump that is used here, the heat exchanger is drawn in this case, and the vapors generated will going back into the distillation column. So bottom product is going or pumped into the heat exchanger. Now the fluid is pumped through the exchanger and vapors formed is separated in the base of the column. The generated vapors, they go into the bottom of a distillation column, and the space which is separating the liquid and the tray, that space will be working as the head space or head room, where the separation of liquid and gases that will take place. When used as a vaporizer for only the disengagement vessel, that will be provided separately. If it is not attached to a distillation column, then sometimes the disengagement vessel or a separate vessel that will be provided for the separation of the vapors and the liquid, so that only vapors will go out and the liquid will be recirculated back. Then slurry, viscous liquid, heavy fouling fluid processes, they are suitable for. So these are suitable for slurry, viscous and heavy fouling process fluid. That is what we have talked related to the nature of the process fluid. Then low vacuum operations, that is related to the operating pressure, and third is the equipment layout. This is the criteria for the selection. So in this case, this forced circulation reboilers, they are suitable for the slurry because we are pumping the fluid. When we are pumping the fluid, we are using the external source of energy, and where the slurry or viscous fluids or heavy fouling fluids, they can be adjusted. Heavy fouling fluids, as the pump is there, so velocities will be more, and as a result the fouling that will be avoided. Now in case of a low vacuum operations also, these pumps, they can be used, and low rate of vaporization, where the fluids are getting, rate of vaporization is the low. The circulation rates are predictable. As you know, the pumping velocity, the fluid which is pumped, so we can put measuring flow measuring equipment in the process line, so that we will be able to calculate the circulation rates, the rate at which the fluid is pumped into the heat exchanger and back, so we can calculate the circulation rates. Then high velocities can be used as we are having the pump. But when the pump is there, you are putting the external source of energy. Cost of pump, the pressure drop will be more, maintenance cost will be more, and for the pumps which are operated at a higher temperature, because this is at the bottom of a distillation column, the temperatures are high, and as a result, for a better pump or for a better leak proof pump, you will require the mechanical seals, and these mechanical seals which prevent the leakages of the pump are very costly. can be of 1 lakh or 2 lakhs also, or more than that. So pumps are required, but the pumping cost, maintenance cost, mechanical seal cost, all these costs, they are involved, and this is what a disadvantage can be. Then the next is a thermosiphon reboiler or a natural circulation reboiler. In this case, the fluid which is moving into the heat exchanger and back into the distillation column is flowing without the pump. So pump is not used in this case. The fluid moves according to the head difference or according to the temperature difference. Delta H rho G. Head difference. Delta H is your head. And if the head difference is there, then the fluid is going to move. Or else the density difference, that will also help to move the fluid from one place to another place. As in case of a convection, we have studied that the fluid actually moves, the hot fluid moves from bottom to the top, and cold fluid molecules, they will move from the top to the bottom. So the same thermosiphoning or natural circulation, that will be there. The liquid circulation through the exchanger is maintained by the difference in the temperatures, difference in the densities between the two phase mixture of vapor and liquid. So one reason is that of a difference in the densities and the single phase liquid in the base of the column. Then the second is the disengagement vessel will be needed if this type of the vaporizer that is used. Now look at this figure, a distillation column, bottom of a distillation column that is provided, that is shown here, and the fluid that moves into the heat exchanger increases temperature, the certain vapor disengagement section that can be provided, and the vapor, they are going back into the distillation column. And similarly in this figure also, bottom of a distillation column, a heat exchanger is there, liquid which is going into the heat exchanger, and the vapors back into the distillation column, and the bottom product that can be taken out. So the disengagement vessel, this extra space that can be considered, or the disengagement space, disengagement vessel will be needed if this type is used as a vaporizer. It is the most economical because we are not using the pump. So pump cost, that will be reduced, and as a result it becomes the economic. This is not suitable for the slurries, high viscous fluids or vacuum operations. As we are not using the pump, the flow is only by the natural temperature difference and the density difference and the head difference. Because of temperature difference, the density difference that will be there, and because of the height, the fluid that will also move from bottom heat exchanger that is provided, so that here the liquid that will be there. So liquid head is at this, and as a result the fluid may move from here to here, and here the vapors, they are generated. So you are putting these generated vapors back into the distillation column. The head difference or the height difference, you can say, is second reason other than the differences in the density. And as a result there is a natural circulation, so we cannot use it for slurries, for high viscous fluids, or for high vacuum operation fluids. And the specified pressure, that is below 0.3 bar, this is by experimentation and by people experience, It is not specified for the pressures below 0.3 bar. Then there are certain disadvantages. Column base must be elevated so that you are going to lift the column. So bottom जो level रखने का है, to create this head difference or the height difference, you have to increase the height of this distillation column, and as a result you may require the more cost for the column support and its structure. जो कुछ structure है बाजू में लगा हुआ, वो structure as well as your column support, that will be more. That is the disadvantage. Then there are vertical heat exchangers, vertical thermosiphon reboilers, as well as the horizontal thermosiphon reboilers that will be there. So two types in this. Now when it's a vertical exchanger, the vaporization takes place in the tubes. Now this is a vertical and this is a horizontal shell and tube heat exchange. In this case of vertical heat exchanger, the fluid that enters inside the tubes. As the fluid enters into the tubes, so the vapors generated are from the tubes. So it's a vaporization in the tubes. And in case of a horizontal exchanger, the vaporization is in the shell. So shell side में fluid is provided in this case of a horizontal shell and tube heat exchanger, a horizontal shell and tube reboiler. Now this horizontal reboiler requires less headroom as compared to the vertical reboiler, so as we can adjust the height difference. Headroom के लिए चाहिए height difference delta H, so that the fluid will be moved by its own. Then more complex pipeline, then easy for maintenance than your vertical reboilers. It is easy to maintain. Then easily removable bundle here. Here whatever the heat exchanger that is there, that bundle that can be removed easily. However, in case of a vertical thermosiphon reboiler, the tube bundle which can be removed, but it requires more efforts. उसको lift करना पड़ता है, upward pull out करना पड़ेगा. यहाँ पे horizontal pull out करना, that is more convenient, and यहाँ पे vertical pull out करना, tube bundle को tube sheet के साथ attached रहने वाला tube bundle, उसको ज़्यादा energy and difficulty लगती है. So these are the different advantages and disadvantages of a thermosiphon reboiler, whether using the vertical exchanger or the horizontal exchanger. Next is the kettle type. This is the third type. Now in this kettle type, the headroom that is already provided for the vapors and the liquid disengagement section. However, the boiling takes place on the tubes immersed in a pool of liquid. Now there is a liquid which is coming from here. This 9 is nothing but the shell inlet nozzle. The fluid is coming in this direction into the shell side. Through the tube side, it's the steam that is there. 5 is the channel inlet nozzle. So in this, the steam that will enter, and the tubes, they will be filled with the steam, and you are supplying the product, bottom product of a distillation column in the shell side, so that this bundle, tube bundle, this is my tube bundle, ये जो है ये tube bundle है, and this tube bundle that should be completely immersed into this liquid which is to be heated. So यहाँ तक पूरा liquid available है, and there is a baffle this 12 number is nothing but the weir, and this weir, it maintains the liquid height up to this, up to the height of the weir. The liquid will be maintained, and this weir height should be always more than the bundle diameter, so that the bundle will be completely immersed in the liquid always. Now whatever the overflow from there above the weir, from this weir, this side the complete fluid that will be there, and whatever the overflow will takes place, that will be crossing this weir, and that is going out. This is the outlet, shell side outlet, that is the nozzle outlet. So shell side fluid outlet will move through this nozzle and will be taken out as the bottom product. So boiling takes place on the tubes immersed in a pool of liquid. There is no circulation of liquid through the exchanger, because whatever the weir excess fluid is there, that excess fluid is taken out and is going out from the bottom of a distillation column. Often used as the vaporizers, as the separate vapor liquid disengagement vessel is not needed. Why it is not needed, disengagement section? Because it is already provided into the shell. As a result, cost of the shell increases when you are providing the extra head space, extra space for a distillation column, for a vapor separation. There this cost of the extra cost of the shell, that has to be afforded. So suitable for the vacuum operations and the higher rates of vaporization. In this case, you get the higher rate of vaporization, low amount of the liquid which is going out. Maximum liquid is vaporized up to the 80% of the feed. 80% of whatever that is feeded in will be going out as the vapors. Now here the three, that is nothing but the entrainment baffle. It is also called the entrainment baffle or the impingement plate in case of your condensators, condensation processes, condensers. It is not suitable for fouling fluids because the velocities are low. We are using the fluid on the shell side, so velocities are low. When the velocities are low, that is the scale formation or the fouling formation, that will be more. So the fluids which are not producing the fouling, they are preferred in this case of the kettle type. Then it is not suitable for having the high residence time. The temperature may degrade the bottom product, and as a result we are restricting the high residence time fluids. Then more expensive because the larger space is provided for the shell. So this extra cost of large shell is for the disengagement of the vapors, and so preferably the tube bundle can be installed in the bottom of the column directly. So this tube bundle, that I can be directly applying or providing into the bottom of a distillation column. So in the bottom of a distillation column, I can provide here the tube bundle, so that the vapor, they will be generated inside the vessel itself. It will not go out and will come back again into the column.